All right, this is what we're going to build today. I've made it as simple as possible. All of the code is in the description, is linked in the description, so you guys can just download it. I also included in a diagram, so you can see how everything is connected. The hardest part of this build was probably taking off the film off of the acrylic. For some reason, that took me a while. Yeah, so this is the build we're going to do today. Are you ready to take over the world? Today we're going to build an obstacle avoidance robot. So I have a kit here, just something you can pick up off of eBay or Amazon. You don't have to get this one necessarily. This one, anyone will do. Just something that has 4 motors and wheels, and that's pretty much it. A few other items that you need is an ultrasonic sensor, an Arduino. I'm using the Nano version of Arduino. You can use anyone. You can use any Arduino. You can use an Uno, Mega, whatever you guys have. But I like the size of this one. It's really small and it does the job. I'm also using a couple of motor drivers. This is DRV8833. They're really cheap. You can pick them up on, again, Amazon and a couple other sites. I'll provide the link in the description. You'll also need a battery. I'm using the, if you have a 7.4 volt battery, you'll need one of these. This is a step down converter, so that converts voltage 11 or 12 volt or 7 volt and down to 5, because that's what the motors are using and that's what you need for the Arduino. It's the 5 volts. I also have an optional item that you don't need for this build, but this is something that I designed, but it allows you to place everything on the board without running a bunch of wires. So this probably reduces about 70% of the wiring that you need, so just the build looks cleaner, but you don't need it. There's no logic on this board. This is how it looks assembled, but as I mentioned, you don't need it. You can just connect everything with wires. So that's just like a cleaner build, and it requires some soldering as well, some headers and soldering, but you can plug everything in, so it's just easy to plug stuff in, and that's what I'm going to use today. So the motor's going here. Yeah. All right, let's move on. Let's assemble our robot. All right, so I've put it together. Let's talk about obstacle avoidance, guys. So there are a few approaches to this, how we can build it. So in order for the robot to avoid obstacles, it has to be able to see what's in front of it, right? So you could use a camera, but it requires some more advanced programming if you want to use a camera and process the images from the camera. Or you can use just see what kind of distance between your robot and the obstacle in front of it. You can use a LiDAR. So this is a LiDAR, so it sends a laser beam. The one drawback that it's kind of expensive for a hobby build. So this is LiDAR Lite V3, and I will be doing another build soon, so I will share with you guys. So like and subscribe if you're interested in seeing that. Another option, this is another LiDAR, but this is not a true laser sensor. This one is just an optical sensor. It sends an infrared signal. It's cheaper. It's much cheaper than this one. So this one is, I think, is about 130 bucks, 150 bucks, depending on the model. And this one is about 60. And then you have the ultrasonic sensor. So it's the least accurate of these three, but it's cheap. It's a fraction of the cost. It's you can buy them probably. You can probably find them for $1 or $2, depending on the vendor. But I would say the most expensive one I've seen probably was $5, $6, so it's not too bad. So it sends a sound signal or a sound wave, and then it measures how long it takes for the wave to get back. Just very similar to what the LiDAR does, but LiDAR does it with laser. Okay, let's take a look at our build over here. So the ultrasonic sensor goes here in the front. Let's talk about how everything is connected. As you can see, we have a couple motor controllers over here. So each controller is responsible for driving 2 motors at a time, and that's the maximum it can drive. Then we have the Arduino Nano over here. And this is our ultrasonic sensor. Alright, let's take a look at the code. I will also show you a diagram so you can see how these components talk to each other. Okay guys, so I connected everything how you see here. You have 4 motors talking to a couple controllers, motor drivers, and this is the Arduino Nano. This is your battery. This is the voltage regulator, so it steps down voltage from 7.4 volt to 5 volts. This is your ultrasonic sensor, and this is how everything should be connected. So you look at the pin numbers, the code matches what you see here. The battery that I'm showing here is 7.4 volts. So that's why I need this voltage regulator. If you have a 5-volt battery, you don't need this piece at all. So you just can connect directly. You can just bypass this. You can see the trigger pin, the echo pin are connected to the to Arduino. You can see the drivers, the motor drivers are connected to Arduino as well. You need to connect each one to ground and 5 volts. Don't drive the motors off of Arduino. You need a separate power supply for the motors, so that's what I'm using the battery for. Just keep that in mind. Now let's take a look at the code. So the link to this code is below, as well as the diagram. You can find it in the description. Anyway, let's just walk through this real quick. I didn't use any external libraries. I just wanted to make it as simple as possible. So there are no dependencies, so it is less likely that you will run into any issues. So let's take a look at the motor pins. So this is how you connect the motor drivers to the Arduino. And it doesn't matter if you use Nano or Uno. These are the pin numbers that you need to use. So your motors will be connected to the drivers, not to the Arduino, just to keep in mind. So you're connecting, these are the connections for the motor drivers, the DRV8833 that I'm using. Again, you don't have to use this particular ones, you can use different ones, but this is how we're connecting this. After we're done setting up the motor pins, we're going to set up the pins for the ultrasonic sensor. So you're connecting them to pin, the echo pin to pin 11 and the trigger pin to pin 10. So you are connecting the ultrasonic sensor directly to Arduino. This is where, and these are the pins that you're using on the Arduino. Then we're setting up a couple of variables to help us with getting the distance, to calculate the distance. After we've done kind of the pin setup, we're going to the setup function of Arduino. We're setting up the motors, we're initializing the ultrasonic sensor, and then we'll come back to the main loop, kind of the main logic, which is very, very simple. We have a few functions here to help us kind of navigate and operate the robot. We have the stop moving function, so it does basically just stops all the motors. We have move forward, backward, turn right, turn left. So the main logic is very simple, but you can make it more advanced if you wanted to. You kind of have all the functions at your disposal now, so you have a mini platform to play with. All we're doing here is we're getting the distance value. If it's more than 35 centimeters, we're just going forward. If it's less or equal to 35 centimeters, we are turning right until the distance increases, until we get a distance that's more than 35 centimeters, and then we're moving backward just a little bit, and then we're moving forward again. So this basic logic allows you to avoid obstacles, and again, this is just, it's very basic. you need, if you have everything at your disposal to make it more advanced. So one way to make this platform more advanced is to add a servo. So the ultrasonic sensor would sit on the servo. So instead of moving the whole platform around, you can just move the servo. So yeah, put this together, play around with it. The links to everything is in the description. I have all the components that I'm using down below, as well as this code and the diagram on how to put this together. If you like what you see, yeah, please subscribe. Okay, now let's test it out. Let's see how our robot performs. Okay, let's try and plug it in, see what happens. As you can see, it works. And that's about it. Thank you guys for watching. If you guys like this video, I'd appreciate it if you hit the subscribe button below and like the video as well. I'm planning to put together a few more of these videos. So there's another robot that I'm planning to build, which is going to be based on a few LiDARs. It's going to be much more advanced than the one we built today. So yeah, please let me know in the comments below if you'd like to see those as well.